we go. So I don't forget. All right. Well, it is 9 o'clock. I'm going to get this lecture started. So we'll start with tracing the code for the homework assignment. So this way we at least know what the answer should look like. And then what we'll do is we'll go back to the last example from the 14th of April, and then we'll kind of work this one out because that's the last one that we have not worked out yet. And then we'll talk about the new homework assignment, which is also on recursion, but it does have arrays in it. Okay, so I'll explain how arrays work as a parameter. So we'll kind of do these things in that particular order. All right, so we'll work with recursion one first. This is the algorithm itself. The algorithm itself is recursive, and recursion or recursive means the function, the code within the function calls the function that is containing the call itself. So in this case, this is function f, and we can see that in function f it has to call itself. That makes it recursive. And in the homework assignment, you're supposed to trace what is f of 3. Okay, so we are going to work this out. The most important part to remember with recursive function calls is that recursion does not make the calling or the returning any more special than it used to be. Okay, in other words, having main to call f and versus having function f to call function f itself, the mechanism is exactly the same. Okay, so this is really a test of whether you understand the mechanism of calling and returning, because once I give you the difficult part about recursion is coming up with the algorithm itself. Now that part can be a little bit tricky, and also it involves more experience. But once the code is given to you, tracing it or following it, reflects whether you really understand function call and return or not. All right, so we're going to do the typical thing, basically, taking a snapshot of the code, okay, which is this part here, and then we'll put it on the side, just as usual. So this way, when we are tracing the algorithm, this is going to be on the screen so we can see what code we are tracking. And then I'm going to use the same Google Sheet to put the answer. So this way, if you want to look at the solution, all you have to do is to go back to your homework assignment and then go to the other tab, the trace tab, so that you can get the solution that way. So I'm going to put it over here, and I'll just change the label to trace to make it very clear. This is about tracing the algorithm. And as usual, we start with only two columns these days. It's just comments and line number because we typically do not want to use global variables anymore. So there are no additional columns to set up at the very beginning. All right, and line number does not need a whole lot of space, so we'll just kind of make it as narrow as possible. So even though I still use pre and post, for the most part, there's really nothing to say about pre or post because there are no variables in existence at this point. So we start execution in main, which is on line 8. Okay, so here's line 8. And when we enter a function, main is just a function, we have to allocate for the local variables of the function. In this case, is the only local variable of main in this case. So x is going to occupy column C, which is the leftmost available column at that time. And then we move on to line 10. So line 10 looks rather simple, and it really is. So we are now invoking or calling a function. So in this class, invoking and calling are basically saying the same thing. Most people use the word call, but sometimes you also have people who go through the computer science program in the 80s or 90s. They would refer to it as invoking a function. So either way is fine. All right, so what do we do when we invoke function f on line 10? So the question is, does f return a value? How do we know whether f returns a value or not? So you have to look at the definition of f. If this is not a void, in other words, if the return type of function f is not void, it means it does return a value. And then you look at the way we invoke function f, we are using the return value of f of 3 to store that value. It specifies a value for us to store into variable x. So that means we cannot use a return line number because return line number is only usable when you are returning to a particular line, but there's nothing else you need to do with the return value in that case. But in this case, we do have to use the return value of f in order to store that into x. So we have to use a single return. And then what we also need to do is to look at function f and ask, does it have any parameters? In this case, it does have one parameter called n. So now we have to allocate a column for n and also a column for, to specify what to do when we return. Um, Parameter n is specified by this argument, which is 3. So that's why, a parameter n in this case starts with a value of 3. And then in order to track what we need to do when we return, we have to specify that we have to go back to line 10. But when we get back on line 10, we still have the assignment operation to perform. But the value, which is now, using the question mark as a placeholder, is going to be resolved by the time we get back to line 10 so that we can complete the assignment operation. So that's what we specify in the return column. So let me just ask, do we have any questions about how we allocate and initialize, columns D and E when we execute line 10 for the first time? In other words, are we understanding what a parameter is? How do we pass a value, which is called an argument, to a parameter? And also what we need in order to keep track of what do we need to do when we come back from the function call in the case of a function returning a value that is going to be utilized. So those are the questions. Okay, if we have any questions about that, now would be a good time to ask those questions. Yep, go ahead. Can you ask the question again, please? Yes, line 10. It is not. It is x equals to, which is an assignment operation, the return value of f of 3. So we're calling function f with an argument of 3. So it is certainly, I mean, it might turn out to be 3, okay? The return value of f of 3 may be 3 itself, but we don't know until we go into the function to figure out what value it is returning. Is that okay? All right. So that is a very important concept. Okay, when you have a function call, how do we know there's a function call? You have the name of a function followed by parentheses. Now, whether you have things or arguments inside the parentheses is kind of besides the point. Okay, but when you see the name of a function, which is f in this case, followed by open and close parentheses, that means we are invoking the function, which means we are calling the function. All right. So let me ask you guys, where do we go next from here? We're calling function f. We set up everything that we need in order to keep track of, what do we do when function f is done. So where do we go next? Yep. And what line would that be? Yep. So line one is good. Okay. So we go to line one, which doesn't do anything, which is okay. Okay. But I do need to indicate that we are going to the function. So technically, line one doesn't do anything. You don't need to track line one, but it represents that we are going to the function. We are in the function now. So now we go to line two, which is a conditional statement. So now we have to ask, is n less than 2? So now we have to remember, how do we resolve, a variable, in this case n? How do we find n? It is the uh, rightmost column that is labeled n. What is the rightmost column that is labeled n? Then, by the way, there's only one column labeled n right now, and that is column D. That is correct. So column D currently has a value of 3. Very good. 3 is less than 2 is Is false. Very good. Okay. So if the condition of a conditional statement is false, we go to the else. So where is the else statement in this case? Line 5 is correct. Very good. So now we go to line 5. And when you go to line 5, okay, there's a whole bunch of stuff that we need to do. Eventually, once we figure out what is f of n minus 1 plus f of n minus 2, we can return that value. But do we know that value right now at this point? Nope, we do not. So we have to say, okay, um, it is the result of an addition, but do we know anything about what we are adding? Nope, we have no idea of what we're adding because the left-hand side of the addition is f of n minus 1, and we don't know what that is, okay? Until we call and execute the function, we don't know what is the return value of f of n minus 1. And then the right-hand side is also f of something, so that means we have to resolve that as well. So are we doing okay so far with what we need to resolve now that we are on line 5? Okay. So that means we have to call f. Okay, you can either call f with n minus one as the argument, or you can call f with n minus 2 as the argument. There's no need to evaluate from left to right in this case. You can evaluate the right hand side first and then the left hand side. It does not really make a difference. But since most people read from left to right in English, so we are going to follow that particular order from left to right. So that means we're going to handle f of n minus 1 first, and then we'll figure out what is f of n minus 2. So that means we have to call f again. Every time we call f, we have to do the same thing. We allocate a column for the parameter, which is n. We allocate a column to specify what do we do when the function call is done. N in this case, okay, parameter n in this case is specified by n minus 1. Now, that sounds really kind of confusing, but when we compute n minus 1, it is referring to the n that is in existence, which is column D. So that is 3. 3 minus 1 is a 2, so that means the argument that we are now specifying is going to be 2 because it is the 3, which is in column D, minus 1. The return information, or what do we do after we return, has to indicate that we have to go back to line 5. And when we get back on line 5, we still have the return to do. The question mark, which is the function call that we are handling right now, will be resolved, but the other function call is still not resolved. So it still has to be written verbatim in the return column. Okay, so let me just kind of do some nice formatting here, and then I will ask you, do we have any questions? Because if there's anything, this is the part that can be a little bit confusing. Okay, and formulating the question itself is going to be kind of like an important process because that's kind of your brain trying to figure out how to do something, even though you're asking me a question. In order to formulate the question, you're already kind of exercising and trying to make all the connections. So I'm going to give you guys a little bit of time to see whether you have a question, and if you do, then you have some time to formulate the question. So how are we doing on row 10 or row 9 and 10 of the trays at this point? Are there any questions about how it is set up? Yes. No, we're invoking f. There's only one function f. We are invoking function f. Yes. So when we evaluate n minus 1 here, that n is referring to the n that is already in existence, which is column D, which has a value of 3. So 3 minus 1 has a value of 2, and that's why we finally decided that when we call f again over here, n minus 1 really evaluates to a value of 2. But that 2 becomes the value of the parameter n in the call that we are setting up right now. So there's a call that we are in right now, and then there's the call that we are setting up at this point. So the important part is to differentiate um, which n refers to the n that is in existence. So when you read the code, this n is referring to the n that is already in existence, which is column D. But when we set up the column, because we're calling something that has a parameter n, that n, which is column F, is referring to the end of the new invocation that we are setting up, but it has not happened yet. So is that okay? Yes, go ahead. hmm Well, we are not there yet. We're only dealing with n minus one right now. So that's why that particular function call on the left-hand side of the addition is now replaced by a single question mark. You can only handle one function call at a time. So that means the return column, the cell in the return column should only have one single question mark, one and only one. If there are no question marks, something is not right. Okay, if you have two question marks, something is also not right. It can only have one and only one question mark because we can only call one function at a time when we are dealing with a single line of code. Are we still doing okay so far? Okay. All right. So now we continue execution at the function that we are calling. Remind me again, what function are we calling on line 5? It's f, right? So where do we start when we execute or when we invoke function f? Line 1 again. Okay? It's line 1 again. And then we fall through to line 2, and now we evaluate the same condition, but this n is referring to a different column compared to row 8, because every time we evaluate something like this, we're asking the question of, okay, where is n? And the answer is always going to be the rightmost column that is labeled n. We have two columns that are labeled n at this point. Column D is labeled n, so is column F. Which one is the rightmost one? Column F, that's right. So column F is the one that is used to evaluate n is less than 2. So that means we're actually asking, is 2 less than 2? The answer is no, that is not the case, so it is false. So after that, we go to line 5 again, and then we go like, okay, we are getting to line 5. We eventually we have to return a value. The value is going to be the sum of the return value of f of n minus 1 and the return value of f of n minus 2. So that means I cannot execute a return statement yet. I cannot even perform the addition because I do not know what I'm adding. So we have to once again evaluate from left to right, okay, to evaluate, okay, let's find out what is f of n minus 1. So when we evaluate this f of n minus 1 on line 5, we go like, okay, what is this n referring to? It's always the same answer. Okay, when you are referencing or when you are evaluating an expression, you always go to the rightmost column that is labeled with the name of the variable. So now we go like, oh, okay, this n here is now referring to column F, which is 2. So 2 minus 1 is a 1. So now we go like, okay, the new parameter to the new function call that I'm setting up right now is going to have parameter n being 1. Okay. And then the return information that we need to track is going to be, it will look exactly the same as this one over here, as a G10 SSL, because we have to go back to line 5 when the function call returns. When it does come back, the question mark, which is a placeholder of the invocation that we're handling right now, is going to have an actual value, but we still have to handle the rest of this entire call, which means we still have the addition, we still have to evaluate what is f of n minus 2 at this point. So now we have set up the two columns that we need for the function call. We now go to line 1 again. Are we doing okay so far? Yep, go ahead. Yes, but we have to remember when you call f, we are using n minus 1, and because n is 2, 2 minus 1 is 1. So yeah, go ahead. for row 10 of the trace, because at this point, when we evaluate line 5, on row 10 here, we the only n in existence is column D, which has a value of 3. So 3 minus 1 is a 2, and that's why, and when we perform the function call according to line 5, we are using 3 minus 1, which is 2, and that's why when we set up the new n for the function call that we are setting up right now, n starts with a value of 2, but it's a new n. It's not the same n as column D. This is a new n. It is column F now. hmm Because okay, because it's 2 minus 1. Because what row 14 or what row 13 and 14 together is representing is when we execute line 5 the first time, what do we need to do? So when you look at line 5 and you look at all the rows before row 13 up to row 12, so this is really asking on line 5 of the code, we are asking, oh, we need to figure out what value we need to return, right? That's the last operation of line 5, but we don't know what value to return until we can figure out what numbers we're adding. And we don't know what numbers we're adding because the left-hand side and the right-hand side of the addition, they're both function calls. They're both calling a function that has a return value. So we have to invoke the function, both on the left-hand side and also on the right-hand side. Is that okay? So we just randomly pick the left-hand side first because that's kind of convention that we read from left to right when we read the program. So that means that we have to handle f of n minus 1 first. So now we ask, okay, we have to call f with the value of n minus 1 as the argument. Is that okay? So now we have to, so that's why we have to evaluate the value of n minus 1. But at that time, okay, remember, this is all prior to row 13 and 14. Okay, I'm trying to explain what we need to do on row 13 and 14 of the trace. So at that point, um, columns H and I have not been allocated yet. So with the absence of columns H and I, when I ask what is the value of n so I can subtract 1, which n do you think it has to refer to? Or which column it has to refer to? It has to refer to column F because when we resolve the name of a variable, we look up the rightmost column that has that name. So at that time, the rightmost column that has the name of n is column F, which has a value of 2. So that 2 goes into the n minus 1, the n of the n minus 1. So we are now actually evaluating 2 minus 1. In other words, we're essentially saying f of 1, okay, to the new function call. So now we switch mode and we say, okay, now that we have resolved the argument inside the parentheses of calling the function, it is now time to set up the columns. So when we set up the columns, in a kind of confusing way, we have to set up a new column with the name n because we're calling f, and the parameter of function f is n. So that is the reason why column H is also labeled n, because the parameter of the function that we are calling has a name of n. But it has a value of 1 because when we evaluate n minus 1 on line 5, and that particular n is referring to column F, which has a value of 2. 2 minus 1 is 1. And that's why we set up column H to also be labeled n, but this time with a value of 1. Okay, so the most important part is to uh, figure out which n we're referring to, because the one n on line 5 of the code, that n refers to the n that we already know. Okay, when we set up the column, which is column H of row 13 of the trace, that's the name of the parameter that of the function that we are calling, which so happens to also be n. Is that okay? All right. So this really is the essence of calling a function with parameters, okay? And it this part has nothing to do with actually recursion, okay? You can have function g and function h, they both have a parameter called n. That can happen too. So in that case, you still have to know which n we are referring to, the end of the parameter that we of the function that we're calling, or the end which is a parameter of the code that is running, that is calling the other function. So we have to kind of resolve here between those two. Are we still doing okay so far? Okay. So this is something that you might want to write some notes on, okay? Because if you're not quite understanding, how this is happening, the first thing you need to do is to write down the time right now, because the recording is, it's on, okay? I double check and make sure that we are still recording, and you might want to come back to this time so that you can revisit, this entire discussion, because this really is important. Is that okay? All right. So now we go back to line one, and line one doesn't do a single thing. We go to line two, and now we ask, is n less than two? So this time, which column are we referring to with this n on row 16 of the trace? It's always going to be the rightmost column that is labeled n, and which one is it? Is column H, which has a value of 1. 1 is less than 2. It's not false anymore. Tag, this is actually true. So if it is true, what is the next line that we need to execute? We're looking at the conditional statement inside function f. Return n, which is line 3. Very good. Okay, so we go to line 3. And in this case, line 3, when we execute a return statement, what do we do when we execute a return statement? So this is, go ahead. All right, so there are three steps to that process, okay? So either you know where to find the instruction of what to do when you execute a return statement, or you write it down in your own words in your notes, okay? So that's something that you really have to do, is either to know where to find it in the notes that I have provided, or you have it in your own notes, okay? That's really a very essential skill set when you are taking a class like this, okay? And I don't see anyone taking notes right now. So I would make the assumption, if I don't see people writing notes or asking questions, I will make the assumption that they're understanding the material, because I am not a mind reader. Neither are your other professors in your future. So if you're not understanding something, you have to ask a question, or you write in your own notes, okay, that I'm not quite understanding this. I might need to spend some time, on this particular topic later on. And if I still do not understand it after spending some time on this topic, then I might need to visit the professor and ask the professor what does this mean and how do I understand this stuff here? Okay, those are essential skills of taking classes like this. Okay, so I will go ahead and remind you guys what a return statement does. It would go to the rightmost column that is labeled return, which in this case is column I. It goes to the value of that column, which is this one here, copy and paste over here, and it will look for the question mark in that cell and replace it with the actual value that we are returning. We are executing line 3, which means we are returning the value of n, and n in this case is column H, because we're referring to the rightmost column that is labeled n, which is column H, which has a value of 1. So we are executing return 1 essentially, which means the question mark is replaced by, that's right, it is returned by a single value of 1, and that's all we do. Well, sort of, that's the first step. And then the second step we do is we copy and paste this to one row after the current row. So this is going to be pasted onto row 19. The reason why we do this is we are tracking what do we need to do, what else do we need to do when we get back to line 5. So once we have figured out, oh, the question mark is really the value, a value of 1, then we have to kind of remind ourselves and go like, okay, when we get back to line 5, that's what we need to do. So we skip one row. Why do we skip one row? What are we supposed to do on row 18? I'm not going to leave an entire row empty. Row 18 serves one purpose, and what does it do? Yes, exactly. Deallocating all the columns that that are corresponding to the invocation that has now concluded. So which two columns are we deallocating in this case? That is correct. Okay, so the way we uh, denote that these columns are deallocated is simply to copy and paste the names of the columns and then strike them out. Okay, so now we are returning back to line 5 of the code. So the code is only referring to this part here. And you can see that the code itself has no idea of the columns. Okay, the code only contains instructions of how to use the columns when we execute the code, but it does not have any information of what the columns look like at this point. And that's why the trace is completely separated from the source code itself. Okay, because the trace is keeping track of the state of everything in the execution of this code, and then the code is just instructions. You can think of the code like a instruction manual. Okay, let's say you work for Amazon. Okay, and there's a huge, gigantic manual of what to do when somebody is requesting a return and want a refund of a product. Okay, so it can contain a bunch of conditional statements. First one is when was the purchase made? Okay, if the purchase was made more than a certain number of days ago, then you do not process that refund. You just tell the customer that this is beyond the point of returning the product. Okay, and if the product was purchased within that range of date, then you ask the customer, okay, how do you want to return it? Do you want to go to the closest Whole Food? Do you want somebody to come pick it up? Blah blah blah. Okay, so those are the instructions. Are you going to use a pen or pencil to mark up the user's manual as you follow the instructions? No. No, your employer will frown at you and then probably fire you right on the spot. You do not mark up the manual itself. So what do you do? How do you keep track of which customer, what is the order number, and so on and so forth? You use post-its. You do not change the user's manual. You use a little post-its, okay, or a form, okay. If the company is good, they give you a form, okay. This form will help you process a refund request, okay. And on the form, it will say, what is the order number, okay? When was the order made? How does the customer want to return the product? So you fill in all those things. The form that you're filling is corresponding to the spreadsheet here. The manual containing the instruction is the code, is the pseudocode, or in this case C++ code. So the code only tells you what to do. But in order to do what the instruction is telling you what to do, and you need to keep track of a lot of things, that's the purpose of the trace itself. And all the columns are corresponding essentially to a form that you need to keep track of as you follow the instructions. So are we doing okay so far? Differentiating what is the source code versus what we are doing with the trace with all the columns in a trace. Yes, because the whole purpose of this column is to remind us what else do we need to do when the function call is done. In other words, when function f is all done, after executing the return statement, where are we going back to and what else do we need to do at where we get back to. So what this is telling us, okay, what this cell is telling us is we have to go back to line 5. When we get back to line 5, this is what line 5 would look like, okay? The only difference between the original line 5 over here and this line 5, which is already having one of the function call resolved, is the function call is now resolved to a value of 1. but we still got stuff to do on line 5. Is that making any sense? Okay. So that is the whole purpose of the return column. And it is also why we copy and paste this cell over here, because this column, which is column B, is a bookmark of saying, where are we, which page, which sentence, which paragraph, and which sentence are we on as we follow the instructions of the instruction manual. Is that okay? That's the whole purpose of column B, is to help us keep track of, oh, okay, I see I was in. Well, column B is just saying which page, which paragraph, and which sentence we are on as we follow the instructions of a manual. That's basically what column B is trying to track. Now, all the pieces of information, in addition to where we are on the instruction manual, those are handled by the rest of the columns. Is that okay? All right. So now that we are done with deallocating column H and I, and we are returning to line 5, and line 5 does not look like the original line 5, because we just resolved what is the value of f of n minus 1, but can we execute this return statement right now? No, we cannot, because even though we have one side of the addition resolved, which is what we need to do is to get the addition to work, we have not yet resolved what is on the right hand side of the addition, which is another call to f, but this time with n minus 2 as the argument to the new call of f. So this time I'm going to go a little bit slower. Okay, we'll look from the perspective of the new line 5 and ask, okay, we're not quite ready to execute the return. We have to call f again, but this time with n minus 2 as the argument. So now without labeling anything, let's find out what is n minus 2 right now. Okay, so let's do that. When we look at a variable, which is n in this case, how do we find the value of the variable? Yes, the rightmost column that name labeled, right? So which column would that be at this point? Column F, okay? So that means what is the value of column F? 2. What is 2 minus 2? 0. Very good. Okay. So that means now we want to call f with an argument of 0. Is that okay? So, okay. So now we try to finish up the rest. What do you do when you are calling function f with an argument of 0? Now that we know the argument is 0, what do we do when we want to say, okay, we have to call a function with an argument of 0? What do we do? Yes. Right, allocate the leftmost available column, which is now column H again, because it was deallocated here. So now it is available to us again. So we want to label this n, and why do we label that n? Because the call to function f, this particular function f, has a parameter called n. That is why we label column H n. Okay, and the value of that parameter is corresponding to the argument that we just figured out a little bit earlier. Can somebody remind me what was the value of the argument? It was a 0. Okay. And now we set up the return again, because we have to go back to line 5 again to do something else. So when we get back to line 5, what does it look like? Okay. We still have to do the return. The 1 plus is already done. And the new function call, the one that we're handling right now, is the function call that is now replaced by a question mark. Okay, so the question mark moved from the left to the right of the addition, because once we get the left-hand side resolved, it is time to resolve the right-hand side. All right, so I'm gonna pause here. Yes, go ahead. Hmm? Because the 0, because when we execute line 5 as it is here on row 19, this is what we are trying to resolve. I don't know what is the right hand side of the addition. I have to call function f with an argument of 0. In other words, f of n minus 2 becomes f of 0. But do we know what is the value of f of 0? It is not necessarily 0. We don't know. So we have to call the function first. So that's why, the 0 of column H is representing the parameter of n. When we call function f again, we'll start with a value of 0. The column I, when we specify the question mark, that is the return value of calling function f, which we don't know yet at this point, because until you execute the return statement of the function that you're calling, you don't know the value that it's going to return. So is that okay? All right. Yep. So what this means is, the way I document this, the way I describe these operations, or the steps to perform these operations, may not be the way that you want to write it down, or may not be the way that you want to use to understand it, which basically means based on the demonstrations in the class, all the questions and answers in the class, you might want to write down your own version of the instructions, just so that it is easier for you to follow and to understand. Okay, that is also what you are supposed to do when you're taking a class at a college level, is to take notes. Okay, um, and then you have to process your notes. For each hour of the lecture, how many hours are we supposed to spend outside of the lecture again? Two, right? How much time did it take you guys to do the homework? I hope not 2 hours. Okay, so that means, if you're not spending 2 extra hours, for each hour of the lecture, it does not necessarily mean that something is not right, okay? Because some people get this material right away. They might have some programming experience before. They might have an aptitude for this kind of thing. It's just a natural um, ability to understand the abstract, stuff that we talk about in this class. So maybe some people do not need all 2 hours, okay? But when we talk about this stuff and you go like, I'm not really understanding how this works, okay? That means, you might need to spend some more time after each lecture to try to understand the material, okay? So that's really important, not only for this class, okay? I'm going to make a bold assumption that some of you may not have taken a lot of college level classes before. That's an assumption on my part, okay? But I do need to emphasize, that in order to succeed in college, um, note taking is important, okay? Reading your notes and reading all the material that I have prepared is important, and being able to ask questions either to yourself or the professor is also really, really important. Okay, and they are particularly important in STEM classes, which this one is. All right. So now that we have set up column H and I can now go to the function that I'm calling, starting on line 1 again. Okay. So line 1 doesn't do a single thing. We go to line 2. Line 2 evaluates what is n is less than 2. So is that true or false? Or better yet, which n are we referring to? It's the same boring answer of the rightmost column that is labeled n, which is column H again, okay, because we reallocated column H to be our new parameter n. That has a value of 0. 0 is less than 2 is true. So now we go to line 3, which is the then statement corresponding to the conditional statement. And at this point, we are executing a return statement. Executing a return statement means copy and paste the return information, change the question mark to the value that we are returning. And what value are we returning this time? A 0. That is correct, because we are returning the value of n, and n is referring to column H, which has a value of 0. So now that we have resolved the question mark to be a 0, we just copy and paste it to the next cell, or the cell following um, the next row, like here, and then we are all done. So that means the columns, the two columns that were allocated for this invocation is now they are now deallocated. Okay, so we just indicate that they're now deallocated. And now we're back to line 5 again. So when we get back to line 5 this time, it is returning 1 plus 0. Do we have any additional function calls that we need to do to resolve what is 1 plus 0? Nope, 1 plus 0 is just 1, so we are essentially returning a value of 1. It is time to execute the return statement itself. Okay, we are now ready to execute a return statement. So what do we do when we execute a return statement? The same boring steps of not yet. Copy, paste, change the question mark to the value that we are returning, copy and paste that cell, to one row after the current one, two rows after the current one, and then deallocate some columns. Okay. So if those steps are not in in your head, okay, that means you might need to either write it down or go through the sample programs some more, okay, because I am assuming that people can remember those steps at this point of this class, okay, because it's kind of important. So now we say, okay, what is the rightmost return? What is the rightmost column that is labeled return right now? It's column G, because it used to be column I, but column I has been deallocated already. So column G is the rightmost column that is labeled return. So we do the same thing here. We copy, paste, and then say, oh, the question mark here is going to be replaced by the value that we are returning by executing what is in column B. So that is returning a value of 1. The question mark is turned into 1. And then we copy this resolved return information to 2 rows below the current one so that we know by the time we get there what to do. And then now column F and G are no longer in use. So we basically just use this little technique to indicate that these two columns are now deallocated, like so. And now execution continue on to line 5 again. Are we still doing okay so far? We're good. Okay, so I can see that a portion of this class is already getting this down, and another portion of this class may not be getting this down. Once again, I'm not a mind reader, so until people just raise their hand and let me know, I do not know. I cannot confirm. Yep. Mm-hmm. Yep. Yeah. So one thing you can do, okay, to confirm your understanding is forget about my trace. Don't look at it. Look at the code again and then redo the homework assignment. Yep. And as you redo the homework assignment, you follow your own instruction. So you write down the instructions the way that you want to write it down instead of the way that I wrote it down, right? And then you check whether the trace that you're producing is the same as this one. So that's one way to do it. Unless you have a photographic memory, which most people do not, especially with something this tedious. When you redo this, and you follow how you follow the instructions as you write it down the way that you want to write it down, and you come up with exactly the same solution. That means, okay, you probably have some evidence showing that you are now getting the concept. You're understanding all the steps. All right. So we are not quite done yet. So we may not have time to start a new homework assignment because I may not have enough time to talk about how do we pass arrays as parameters, but that's okay. Okay, we can go a little bit slower. Okay, there's really no particular mark that we have to hit to get you guys ready for CISP 360. I think we are at least as good as any other CISP 300 at this point. Okay, so we can kind of slow down the pace a little bit, but we need to get all of these concepts down. So now we're trying to execute line 5 as it is now. Do I know what to return? Can I execute the return statement? Because the expression of what we're returning still has one function called left, which is f of n minus 2. So now what do we do? Well, the first thing we do, okay, this is something that you might want to write down because I did not make this very explicit in my notes, is when we try to do this, we have to say, we have to call function f again, but this time the argument is n minus 2. How do we evaluate n minus 2? Well, the first thing is we have to find n, right? How do we find n? The rightmost column that is labeled n, right? So let's see what column it is, okay? Because column F is now deallocated. The only column that is left that is labeled n is column D, which has a value of 3. Okay, so n minus 2 is essentially 3 minus 2, which is 1, okay? So we are attempting to call function f with an argument of 1. So before I go any further, what is an argument and what is a parameter? Those two are similar concepts. They're related, but they're not the same thing. Yes, yes, yes. That is correct. So the way you can remember this, okay, if you're kind of more, you like analogies, this is an analogy. So if you think about the DMV, okay, um, let's say there's a worker at DMV, and they have trays, okay, there's an in tray of incoming, let's say, vehicle registration, okay, there's an in tray labeled exactly, um, vehicle registration. That name, the label of the tray, is the parameter, okay. Now when you are the, um, client, okay, so you just got a new car, and then you go like, okay, I need to register the car. You fill in the form, right? The form that you put into the tray, that form is the argument. So you put an argument, which is a form that you have filled, into a tray. The tray or the label of the tray is the parameter. Is that okay? Okay, because it is really important to make that differentiation, because without understanding the differentiation between an argument versus a parameter, that means we have just wasted 15 minutes of today's class because I kept referring to those two terms. Is that okay? So that's important. All right. So now that we have figured out the argument, which is the field form, is 1, we also figure out that in order to call f, there's an in trade labeled n. So what do we do? We basically have to allocate a column for the in tray, which is labeled n, and it is going to start with the argument that we have just figured out, which is 1. Is that okay? So I'm explaining this in a slightly different ways just so that, to try to help people understand the steps that are involved. But because you're calling a function that has a return value, so that means you also have to keep track of what else do we have to do when the function is done. So that's the job of column G, which specifies what do we do after we return. After we return, we are going to return to line 5. We still have to execute a return statement, and we also have to execute 1 plus whatever f of 1 is going to return. Because we know n minus 2 is 1, we know that we have to call function f with an argument of 1. Whatever that return value turns out to be is replaced by a single question mark as a placeholder, which is, you know, it's basically a placeholder for the function that we are calling to say, okay, when you execute a return statement, that is the spot where the return value needs to go. That's the purpose of the question mark. So now we continue execution on line 1 again. Okay, line 1, there's nothing to do. Here's line 2. Line 2 is evaluating its n less than 2. Which n are we referring to? Now we actually have 2 columns labeled n, but since we're only interested in the rightmost one, we can see it right here. Is 1, right? N has a value of 1. 1 is less than 2 is true. So we go to line 3. Line 3 is a return statement. Are we ready to execute line 3 at this point? Okay, we are ready because it doesn't have any call to any function, so we are ready to evaluate the expression. The expression of line 3 is a simple reference to n. Can someone tell me what is the value of n? 1, that is correct because it's the rightmost column that is labeled n, which has a value of 1. So that means we're executing the return 1 statement because n equals to 1. So what do we do again when we execute a return statement? This is probably the fourth time we do it today. Copy and paste the rightmost return column, right? And then we go like, okay, we need to replace the question mark with the value that we are returning. And what value are we returning again? 1, that is correct, okay? So you do not replace this with a 2, you do not execute this statement. This is a reminder of what we need to do when we get back to line 5, okay? Even though, so we are not on line 5 right now, we're executing line 3, we are not on line 5. So we copy and paste this to, the 2 cells below this, and the whole reason why we have to skip one particular row is because we have to now say, oh, we are now done with this particular function invocation. So now we can close the whole thing and deallocate the columns that were allocated to this invocation. Now execution goes back to line 5. Okay, what do we do when we get back to line 5 at this point? Can we execute the return statement now? Yep, because we still have to figure out the addition, but that's okay. We know what is the left-hand side of the addition. It's 1. We know what is the right-hand side of the addition. It is also 1. 1 plus 1 is 2. Essentially, we're executing the statement as return 2. Okay? And once again, what do we do when we execute the statement of return 2? This is the 5th time we execute a return statement today. So what do we do when we execute a return statement? We look up the rightmost return column. We copy and paste the cell. And then what do we do? What do we do with the question mark? Replace the question mark with the value that we are returning, which is 2. That is correct. Do we update X at this point, which is column C? We do not. Okay, all we do is do this and then copy it over here. Oh, okay, I forgot to Control C first. So we copy over here because remember, this is column E is a reminder of when we get back to line 10, that's what we need to do. But we are actually executing the statement on line 5 at this point. So the change to the return information is simply to resolve a unknown that we had earlier so that when we get back to line 10, we potentially can finish up the entire operation on line 10. I skip a row here because column D and E are no longer needed. We have concluded that particular invocation. So that means now column D and E are both deallocated and the execution. Oh, okay, I just pressed some key that I did not intend to click. There we go. So we have to. So now execution continues on line 10. Can we execute the assignment at this point? Do we know what value we need, what value we are going to use to update variable x? Yeah, I think so. I mean, it says right here, change x to 2. Okay, cool. Where is x? Well, yeah, for this, you kind of have to scroll up a little bit because column C is labeled X. It's the only column that is labeled X. So that means when we perform the assignment operation, column C is the one that is now updated to a value of 2, and that concludes the execution of the assignment on line 10. In other words, line 10 and line 5, they both have a bunch of operations to perform in a particular order. You cannot do it like just once and be able to go like, oh, okay, this is exactly what we need to do. You kind of have to do it in steps, okay? So now that we are done with line 10, we move on to line 11. And line 11 is returning to, returning from main, which we don't really kind of explain what it is actually doing, other than, all the um, local variables are no longer in use, so we have to deallocate X at this point, and then we get to post, which marks the end of the trace. So that is the solution of the homework assignment. All right, yes. Yep. Okay. But as we follow the trace now in this class, in this particular lecture, are we getting those questions resolved? Okay. Okay. All right. So what that means is, the homework assignment is really doing what it is supposed to. Each homework assignment carries a relatively small amount of points, from the perspective of the 100% for determining your actual grade out of this class, because all the homework assignments only add up to how many percent of your overall score? 20%. That's right. Okay. And that's all the homework assignment. So that means each homework assignment is only carrying a relatively small percentage of your entire score. We only have one exam left, which is 40% of your entire score. So the final exam is much more important than one single homework assignment. Does that mean you can just kind of skip over a homework assignment because it doesn't have a whole lot of point impact? No, because the homework assignment is where it will tell you whether you're understanding the concepts or not. Okay, so this happened to exactly my CISP 310 class last night in the evening. Even people who did not turn in a solution that completely worked, okay, and they go like, okay, I can only finish a part of it because I don't really know what to do with the other part. It is still important. Understanding or realizing that you're not fully understanding everything, there are certain steps you're not really figuring out what to do, is important. Knowing or realizing what you do not know and realizing what you do not understand is a superpower. Why do you think it is a superpower? Because you know then what to do. Okay? Not realizing what people know, what they do not know, and not realizing what they do not understand is a huge problem. Okay? You know, uh, doing a homework assignment, only to find out that, oh man, I do not quite understand how to do this. That's okay. Okay, the point value is relatively small. It gives you a chance to go like, okay, now I need to go back and revisit these topics. I might need to ask the professor for some clarification. I might need to go back to my own notes or rewatch some of the videos in order to slow down and go like, okay, do I really understand what my professor was doing, from here to here? Okay, that is kind of what some people need to do. Okay, if you do this homework assignment and you realize that, okay, I'm not quite understanding the whole thing, I hope this helps. Okay, I hope this demonstration helps. And if it does help, then as I said a little bit earlier, um, redo the homework assignment. Okay, I cannot let you guys turn it in again, because just because I got the whole thing already resolved and this is in a shared drive. I don't want people just kind of copy and paste this entire spreadsheet, turn it in again, because that also defeats the whole purpose. So you have to be honest with yourself. Okay, if you say, okay, this is not exactly the answer that I got, then go ahead and do this all over again. Okay, but without following the lecture, without following the video recording, just do the entire thing all over again by yourself. But before you do that, jot down all the notes. Okay, jot down how to go from one step to another step. What does it mean to execute a return statement? What does it mean to call a function? What is an argument? What is a parameter? How do they relate? Jot down all the notes that you might need in order to trace the code again, then go trace the code again, following your own instruction. Now, if the result of redoing the homework assignment, following your own instruction, yields exactly the same result over here, then it's evidence that you're getting it. Okay, or at least the instruction that you wrote for yourself is correct. And that is the most important part, is not to memorize what I say. It is not to copy and paste my notes onto yours. It is to write your own notes, okay, and be able to follow your own instruction, your own notes, so that you basically get the same result because that's an indication that you're really getting it. So are we good so far in terms of that portion? We good? All right. But you have to spend the time to do it, okay? Because if you don't spend the time to do it, that this stuff will just kind of go over your head. You might be understanding, or you might think that you're understanding all of this, but by the time we get to the final exam, you may not be able to do it for one simple reason. Short-term memory is called short-term because it is short-term. Okay, how short are we talking about? Okay, I'll give you guys kind of like some orders of magnitude. Are we talking about tens of seconds? Are we talking about tens of minutes? Or are we talking about tens of hours when we talk about short-term memory? Tens of seconds, which means if you did not write down any notes, okay, and you do not rewatch the video and you do not do anything to record what I said, and these are new concepts to you, you can only retain that for tens of seconds. Now, you might say, but it has been almost an hour since the beginning of the class. I'm still retaining that. Well, it's for one simple reason because I kept repeating the same thing over and over again. There were what, five or six, return statements here that I executed, and every time I repeat that, it refreshed your memory. But if I did not do that, okay, and these are new concepts to you, you would have lost that understanding. Even at the time you go like, okay, I fully understand what's going on here, okay, but in tens of seconds, your mind would have lost it, and that's why we have to take notes. Are we doing okay with that concept? Okay, I know this is not related to algorithm design or problem solving or coding in general, but it really is an important aspect of taking classes is taking notes. So I'm not the only person saying this. Okay, there is an entire book written about this. It relates note taking as having a second brain. Okay, it's really catchy, but what it really is talking about note taking techniques and why it is important to take notes. The book has an entire website, dedicated to, what they call building a second brain. But the bottom line is note taking. Okay, so I cannot overemphasize the importance of doing this, in a class, especially a STEM class at a college level. Is that okay? Uh, yep. How do you take notes? What do you write in your notes? Hmm. Yep, that is correct. Yep. Hmm. Hmm. Yep. Yep. There are a few things, so with this lecture, with the way that I do my lectures, taking notes can be a little bit different from the other classes. So let's say you're taking a class where the professor does not do the recording, does not push the recording on YouTube, then you probably have to take more complete notes, right? Whatever the professor writes on the board, you might have to jot it down too. Exactly. But in this class, this is all recorded, right? Along with my voice, all the sample programs that we have traced, all the previous homework assignments, they're on Google Drive already. You can always go back to that. So it doesn't make sense for you to spend a lot of time, to busy copying everything that I write down, in the Google Sheets. But what I cannot write down, what I cannot record, are your own thoughts. Okay. So when you encounter something, you go like, I'm not quite getting this. I might need to go back and revisit this. That is what you need to jot down. And also the time. Okay. Because as you write down the question that is in your head and also the time, that will give you a clue of approximately which part of the lecture you might need to go back to to kind of listen to what I said or the demonstration at a slower pace. Most people, when they watch my video, they go like 2x the speed. No, you want to go slower. Okay, you want to read, watch it for maybe 2 or 3 sentences, pause. Okay, and then you go like, okay, am I understanding exactly what Professor Takio said in those like 20 seconds or so? If so, you go like, okay, cool. Can I write it down in my own words, in my own way to explain the same thing to myself? You jot it down. Do you have to write it or can you type it? It's up to you. Okay, whatever you want to do, record your own understanding in your own words. Okay, then you unpause, move on a little bit. Okay, so that is how I would imagine people can take notes in this class. It's not so much to write down everything that I put onto the projector. You might want to write down certain things, okay, that might be important to you. You go like, okay, these are things that I kind of missed, when I read the material, but now, I'm kind of backfilling all that stuff. The most important part are your own thoughts, your own understanding of the material, and the connections that you have made in your head. Because I might not have said something and you realize it. You have a eureka moment. You have to write that down, okay? Because otherwise, what you just go like, oh, now I'm finally making a connection between these two things, that's short term. If you don't write it down, you're going to lose it. I can personally tell you that there are many eureka moments of my own, timeline. And later on, I just go like, okay, I had a eureka moment that was important, but what was it? And I cannot remember because I did not write it down. Okay. So all of those are important, important techniques. For those of you who are thinking, okay, but how do I take notes? There's no single way to do it. Okay, what I suggested is just me trying to emulate to be a student of my own class and go like, given that that there are video recordings and whatnot, what else do I need to do? But you can always look it up. Okay, you can just type in a Google search. Okay, um, uh, note taking techniques. Okay, and there are tons of these. The Cornell method is really well known. Some high schools actually teach the Cornell method. So some of these, depends on which high school you attended, and they might have mentioned some of these techniques, or they might not have mentioned some of these techniques. So that's important. If you want to use, ChatGPT, it is good to use it too. Okay, you can just ask a general question, like, I can even tell it something about myself. Okay, I have ADHD and I am taking a challenging STEM class. What are some of the, okay, let me get rid of this because we don't need that anymore. Um, Effective methods of taking notes. There we go. I mean, you really just do this, okay? It's not bad, okay? For students with ADHD taking a challenging STEM class, effective note-taking methods should support focus, organization, and active engagement, blah, 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 okay? It gives you suggestions. And at the end of all the suggestions, it would even ask you, would you like to explore some of these options that I have mentioned? So if one of these is really speaking to you, it's like, oh, this is kind of cool. I want to use digital note taking with voice or tag. Then you can just ask it for more uh, steps. Would you like a printable or digital template for one of these methods? It's easy, okay? It is easy to look up what you need to do. The difficult part is to do it. I have to say it. The difficult part is to go like, okay, I have to do it in a consistent way. So for that to happen, most people think, oh, it's a willpower thing. No, it is not. It is about structure. Okay. It is about structure. It's about your environment. By being here, taking an in-person class, you're already a little bit better compared to taking this as an online asynchronous class. Can you imagine this class being online and asynchronous, where I just give you some reading material and I just kind of leave you guys alone to do the homework and I just do the grading, or the system does the grading? And most people will be playing, League of Legends or something else, when they are quote unquote studying, because you're at home in your room with your own computer that has all the video games installed, okay? Or you're on X, or you're on some other social platform because it's easy. The classroom is part of the structure. What about note taking? Okay, what kind of structure will support note taking? Buddy up. Okay, find someone in this class or even in another class. Okay, so you can say, okay, I'm going to share notes with the other person or compare notes. Okay, what did you get in that class? Okay, show me your notes, and I'm going to show you my notes to you. So now you have a structure. You have someone else that is participating, someone who will remind you. It's like, oh, what do you mean by you did not take notes on that day? Right? That is structure. So you have to set up the structure to support whatever habit that you're trying to build. It is not about willpower. If you rely only on willpower, it's not going to work reliably. You have to set up a structure in terms of people, time, place, location, and so on, in order to establish a habit. And this is a habit. Note taking is a habit. Some people do it without having to think about it because that's what they have been doing for years. Is that okay? I know I have just spent some time to talk about things that are not related to computer science or programming, but having these things in place is important. This is one of the very few semesters when I get to teach this class. I only teach mostly capstone classes in terms of the CISP hierarchy. So by the time the students, take my classes, it is quote unquote a little bit late. Not too late, but a little bit late to start to establish these habits. If you are relatively new to college, you're still early, okay? Which means learning these habits, learning these techniques is going to help you and benefit your many other classes that you're going to take. So that's why I'm doing this. Okay. Um, is that okay? Any questions, comments? How many people actually learned how to take notes from high school? You actually have teachers telling you how to do it. Mm-hmm. 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 Okay. Mm-hmm. 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 To represent the rules, the same rules, but you're representing using your own words. So what about you? What did you learn from high school about note taking? Mm-hmm. Okay. Second nature. Mm-hmm. Mm-hmm. Yeah. You can also give me feedback, like, if there are certain parts of the notes, it's like, okay, this is kind of vague, it can be more clear. You can always give me some feedback because it's OER, which is Open Educational Resources. I develop all this stuff, so it's easy for me to go back and add more and clarify the instructions. So that's also helpful because, when you go like, oh, I'm actually giving the professor some suggestions, you know, you feel good about the whole thing, and that also encourages you to read the notes and go like, okay, let me see what else I can help with clarifying the content. Recursion 2 is going to be postponed. I cannot give you guys that homework assignment, so it's going to be postponed until next Monday because we haven't talked about how to pass arrays as parameters, which is really the key to that particular homework assignment. So ignore recursion 2 as a homework assignment because we are not ready to do it yet. Okay, I did not anticipate spending today's class on recursion one and also on note-taking techniques. So it's okay. We have time. We can do that. But before we leave, do you want to share what you learned in note-taking? Same, Cornell. Okay. Hmm. Yeah. It's not so much the format that is important because Cornell is really just a format, right? This is a part for you to do this, this is a part for you to do this, and this is the main part that you need to do, blah blah blah. It is not about the format. It is about the process. It is about what you capture in the notes. It is about do you know what is important to capture in the notes? So those are the important questions. So I hope you guys are continuing to refine, your note-taking, techniques. Because this is a challenging class. I mean, but compared to many other classes that are yet to come, I would say this is probably about medium. Okay, I wouldn't say this one is particularly hard. All right. All right. So we are out of time today. I will see you all on Monday, but you can go ahead and read the module on parameters because I extended it a little bit. So go back and read it again so that we'll be ready to talk about the homework assignment next Monday. So other than that, have a nice weekend. I'll see you in 4 days. Yes. Hmm. Hmm. I will give you most of the points. But it's important to record it as the way that I did it, not because I just want to stick to the rules, but because the whole idea of using the return column, like this one, using a return column, yeah. So, but the whole point, okay, so that's line five, right? Yeah, because the two doesn't tell you what you're doing, what you need to do with the two. But when we specify return 1 plus 1, it tells me what we are doing with 1 plus 1. In other words, I'm preserving almost the entire line and only replacing the part that I have resolved so that by the time I get back to that line, I go like, okay, so these are all the other things that I need to do on that line, depending on how much I need to do. So I want to explain why I do it the way that I do it. Um, so your method is going to work if you can mentally track what line 5 is about and what you're going to do with the value that you just resolved. But in a more complicated program, you cannot do it. And also, this method is very mechanical, which is boring because it's mechanical. But at the same time, it is also giving you an insight of uh, the mechanical aspect of how a program executes, which is what I really want people to understand is the mechanical aspect of what happens when a program executes. So I just want to explain that to you because I don't want to just tell you, oh, just do it the way that I tell you to do. But there's a reason why I do it the way that I do it. Yeah, because otherwise you don't know what else you need to do on line five, unless you go back to this to the code. Yep, yep. You're welcome. So I somehow get the sense that you also learned how to take notes before this class.